All right, everybody, welcome to the new chapter. This is Unit 6, Class 1 of Unit 6. Please go to the 5.1 workspace underneath Notes. It may just say 5 here, like it didn't come through on your end perfectly. So I think it just says, under Class Notes, it just says 5, so change it to 5.1 workspace. We're going to do a warm-up problem here. Number 1 is going to be 9/25. We are comparing this to 11/30. The first thing I want you to do is to find the LCD. So let's all take a moment and find the LCD, least common denominator of 25 and 30. So I'm going to pause the video now while you guys do that. If you're at home, please pause the video and find the LCD first. There's other stuff we're going to do after that, but all right, so there's a couple ways to do this. One way is to write out all the multiples of 25 and 30. When you do that, you see 150 is the LCD of 9/25 and 11/30. So 150, the alternative way to do this is 25 is equal to 5 times 5. 30 is equal to 2 times 3 times 5. Okay. So the process for finding the least common multiple, look for common factors, so 5, write that down. And then we have no other matches, or no other common factors, I should say. So just write everything that remains down: 5, 3, and 2. 5 times 5 is 25. 25 times 3 is 75. 75 multiplied by 2 is 150. So either way, we get 150. So 150 is our LCD. Step 2 here, after you've found the LCD of 150, I want you to convert these fractions so they both have the same denominator. So convert to the LCD. So right now we have a denominator of 25 and a denominator of 30. Convert so that we have a denominator of 150. So I'm going to pause the video now while you work on that. Okay, focusing first on 9/25. 25 multiplied by something is 150. So 25 times 4 is 100. So 25 times what is 150? 6, right? 25 multiplied by 6, 25 6 times, right? 1, 2, 3, 4, that's 100. 5 of them is 125, 6 of them is 150. What do we have to put up in the numerator here? 6. All right, what's 9 times 6? 54. So 9/25 becomes 54 150th. 54, we're not going to, because we want to have a common denominator so that we can easily compare these fractions. If you simplified it, what would it simplify back to? 9/25, and we don't want to do that right now. Okay, same thing for 11/30. 30 multiplied by what is 150? Yep. 3 multiplied by 5 is 15, so 30 multiplied by 5 is 150. What do we have to put in the numerator? 5 as well. What's 11 times 5? 55. So we get 55 over 150. So up here, 11/30 becomes 55 over 150. So which one is greater? Oh, by the way, that's step number 3 here, I should say. We've now converted. So we want to now write less than, greater than, or equal. So what sign goes here? Shout it out. Less than, right? 54 150th is less than 55 150ths, and then we have a less than sign up here as well. So there we go. Questions on that? Okay. We got another warm-up problem. This is our second warm-up problem and our final warm-up problem. Number 2, I want you to evaluate 3 to the power of negative 3. 3 to the power of negative 3. This is from last chapter. See if you remember how to do that. How do you work with negative exponents? I'm going to pause the video now while you work on that. Who can tell me what we do when we have a negative exponent? Kendall.
You have to move the exponent to the bottom.
Yeah, we're going to move
1 over.
We're going to move this to the other side of the fraction. So we have a negative exponent here. If I take 3 to the power of negative 3 and I move it to the denominator, it becomes 3 to the power of 3, right? So when you move a power to the other side of the fraction, the sign of the exponent changes. So instead of 3 to the power of negative 3, now it's 3 to the power of 3, but it's in the denominator. What remains up top? 1. Okay, so 1 over, what's 3 times 3? 9. What's 9 times 3? 27. So 1/27. Questions on that?
Could you also move the 27 into the numerator to the negative sign?
No. No. So 1/27 is not the same thing as negative 27. It is the same thing as 27 to the power of negative 1, though. These two are equal to each other, but that right there, these two are equal to each other. But yeah. By the way, if I ever fall behind that little banner thing, just let me know. If I'm like talking and I'm behind that banner, just let me know and I'll slide to the right. All right, on to the prep section today. We've got some concepts that I need you to fully understand before we dive into the new material. This stuff you're about to see is not new. And in fact, you should be quite confident in it. Write down 12 multiplied by 10. See if you know what that is. 120. So when we multiply by 10, what do we do, Oliver? What? Add a 0 to it. Now we're going to add a wrinkle to that on the second one here. 3.5 multiplied by 10. See if you know what that is. 5, yeah, this is equal to 35. So what's the, I don't want to call it a trick, but what's the rule when we multiply by 10 and we have a decimal in there? Zella? Slide the decimal 1 space to the right. So if you didn't know that, now you know it. It's not overly complex. C, what if we had this? 84.26, and we multiplied it by 100. See if you can figure out what that would be. 8,426. So Veda, if you earlier we were multiplying by 10 and we moved our decimal 1 spot to the right. Now we're multiplying by 100 and you move the decimal how far?
2.
Yeah, 2 places to the right. So if you multiply by 100, the rule is this: however many zeros you have, that's how many places to the right the decimal will go. Sarah Kate.
So if that was 1,000, it would be 84,260.
Correct. Yeah. So if we were multiplying by 1,000, you would slide the decimal 1 more spot to the right, which would give you that. That's not what was happening, but yeah, if you multiply by 1,000 instead of 100, you would have 84,260. All right, one more. C, and no, D on this one. Let's see, last one in this section. 0, oh, let me do this in blue. 0.12642 multiplied by 1,000. See if you know what this is. So give that a shot. I'll pause the video now. Please pause it at home. Work this out. All right, Kyle, what do you think?
126.42.
All right, so this. So if we're multiplying by 1,000, remember if we multiply by 10, we slide the decimal 1 spot to the right. If we multiply by 100, 2 places to the right. If we multiply by 1,000, 1, 2, 3 places to the right, which does put us at 126.42. Again, the rule is however many zeros you have, that's how many places the decimal moves to the right. Questions on that? We feel pretty confident in that. That's a concept you have to know as we move into what's coming next. All right, so let's talk about this 0.4, and we put that bar over the top. Does anybody know what this bar means over the top of the 4? Taylor?
It means the 4 keeps on going.
Yeah, the 4 keeps on going. So this is 0.44444, and then we'll do dot, dot, dot to show that it goes on forever. So you need to, if you didn't know this before right this second, that's okay. Not everybody saw this in 6th grade, but when we have this bar over the top of a digit, like a 4 in this case, that means that goes on forever. Okay? So let's try another one. B, let's say B was 7.2222, and it goes on forever like that. Rewrite that so that you have the repeating decimal symbol in there. So 7.2 repeating, the 2 is repeating, so the bar goes just over the 2. These two are now equal to each other. Let's try another one. C. What if we had 0.28 with the bar over the 2 and the 8? See if you can figure out what that would equal. Okay, so 0.2888, here's the problem with this. The bar is not just over the 8, right? The bar is over the 2 and the 8, which means the 2 and the 8 need to repeat. So it's going to be 0.28, 28, 28, 28 forever. Okay? That pattern repeats. 28, 28, 28, 28 forever. You guys got that? All right. Let's try one more. D here. What if we had 0.126 with the bar over the 2 and the 6? What would that be? Yeah. So notice the repeating symbol is only over the 2 and the 6, not the 1. So 0.1, and then it's going to be 262626 forever. 262626, dot, 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 forever. You feeling pretty good about this? Okay, good. Not overly complex, but again, it's one of those things, if you don't pay attention, you're just not going to learn it. So good thing you're paying attention. All right, let's move on to like what I'm going to call the content section. Content. So this is like today's new material. Okay. We are going to be converting repeating decimals into fractions, simplified fractions. So number 1 is going to be this, 0.4 repeating. So anytime we work a problem like this, we always ask ourselves the same question first. And that question is, how many digits are repeating? Well, think about what we just did. 0.4 repeating is 0.44444. So how many digits repeat? Just the 1, right? And if we only have 1 digit repeating, here's what we're going to do. We're going to say n is equal to, whatever that number is, 0.4 repeating. All right, so n is always going to be equal to whatever we were given, the decimal we are going to convert to a fraction. And you said there's how many digits repeating? 1, right? So we need to move our decimal 1 spot to the right. So what do I need to multiply by to move that decimal 1 spot to the right, Taylor?
10.
10. Here's the rule of thumb. However many digits repeat, you need that many zeros when you multiply by n. So if we're multiplying n by 10, that will move the decimal 1 spot to the right. So if we move this 1 spot to the right, what's now in the 1 spot?
4.
4, right? If we're sliding this decimal to the right, we now have a 4 in the 1 spot. Everybody good with that? Now, remember, this is 0.4 repeating forever. So what is to the right of our decimal here? It's going to be 4. Because this is like, remember, this is 4, 4, 4, 4, 4, 4, 4 forever, right? And so when you slide that decimal 1 spot to the right, what's going to be right behind that 4 here? It's just another 4. And it's going to go on forever. Everybody with me on this so far? Again, what are we doing? We are converting this repeating decimal to a fraction. How do we do that? We say this repeating decimal is equal to n. Then we ask ourselves, how many decimals repeat? The answer is 1. Just the 4 is repeating. If 1 is repeating, we need to move that decimal 1 spot to the right, which means we have to multiply by 10. So n multiplied by 10 is going to give us 4.4 repeating. Now, here's what we do. We're going to subtract. So let's write minus. Okay, what is 10n minus n? Kyle, what do you think? 10n minus n. What's 10 minus 1? 9, right? So 10n minus 1n is 9n equals, okay, now, look at this decimal. To the right of it, we have 0.4 repeating. Look at this decimal. To the right of it, we have 0.4 repeating. When we subtract these, what is that going to become? Yeah, right? So 0.4 repeating, like 0.4 forever, minus 0.4 forever, that's going to become 0. What is 4 minus 0? 4. Are we good on that? Right? These go away. Because 0.4 repeating minus 0.4 repeating, gone. 4 minus 4 is 0, 4 minus 4 is 0, 4 minus 4 is 0. You get the idea. Now remember, we said n is equal to the decimal we are trying to convert into a fraction. So n is right here. We want to convert n, or 0.4 repeating, into a fraction. So I want to solve for n. Any idea how I can solve for n? Kendall, what do you think? 9 times n. How can I isolate that n? Kendall, yeah. What's the inverse of multiplication? Yeah, so we divide by 9 on both sides. What's 9 divided by 9? 1. So we're left with n is equal to 4/9. So this repeating decimal is equal to 4/9. That's tough. I know that's tough. And it's the first time you've ever seen it. So to be a little confused right now is okay. We're going to work many of these today. We will continue tomorrow as well. Let's try another one. Number 2 here. 0.3 repeating. Now you may already know what this is going to be as a fraction. That's great. Use the same method we just used to show what this is as a fraction. So first off, what's the first thing we do? We say n is equal to. What is n going to be equal to, y'all? Somebody other than Taylor? What? 0.3 repeating. So whatever decimal you are trying to convert to a fraction, that is what n is equal to. Now, Sarah Kate, make sure you pull your mask up. What question do we ask ourselves at this point? How many, Lucy?
How many spaces there are with the decimal?
Yeah, like how many digits repeat? So how many digits are repeating here? Just 1. So n is going to have to be multiplied by what? 10. However many digits repeat, that's how far you need to move the decimal. So if 1 digit repeats, we got to multiply by 10. All right. Avery, if we multiply by 10, that decimal moves 1 spot to the right. So we end up with what in the ones place? 3. And then point, what's to the right of this 3?
3.
Yeah, 3 is forever. So what goes in this place? 3, and then with the repeating symbol over the top of it. Yes, Sarah Kate?
Wouldn't it be 10 point n?
No, it's 10 multiplied by n. Because remember, we want to move that decimal 1 spot over. We now, you might know what we do next? Kyle?
We divide.
First we subtract. First we subtract. Okay. Oliver, what is 10n minus n? 9n. Jack, this 0.3 repeating minus the 0.3 repeating, what's going to happen here? That becomes what? Yeah, it becomes 0, right? And so then 3 minus 0 is what? 3, right? So just to recap, those get canceled out. There it becomes 0. 0.3 repeating minus 0.3 repeating goes away forever. It's gone. Now, to solve for n, remember n was the decimal we wanted to convert to a fraction. To solve for n, Bennett, what do we have to do here? We want to solve for n. What's happening between the 9 and the n? Multiplication. What's the inverse of multiplication? So we're going to divide by 9 on both sides. So we're going to say n is equal to 3/9. Now, what's the problem with 3/9? Lucy, what? It's not simplified. So 3/9 is the same thing as what? 1/3. We can divide both those by 3. When we do, we get 1/3. So maybe you knew coming in that 0.3 repeating was 1/3. Maybe you didn't, but there's a proof that 0.3 repeating is 1/3. Here we go, third one. We're going to change it up a little bit. 7.2 repeating. 7.2 repeating. Okay, now, this has a number to the left of the decimal. It's really not any more complex. We're going to make what's called a mixed number. A mixed number. So let's take that number to the left of the decimal, which is 7. I'm going to just write it out here. And then we got to figure out what 0.2 is as a fraction. So we're just going to worry about the 0.2. Ignore the 7 for now. We're just going to have it here kind of off to the side to create our mixed number later. So what is n going to equal here? Zella, what do you think? What does n equal to here? 0.2 repeating. Okay. Veda, what do we have to multiply by? 10, right? So n multiplied by 10. And when we do, that decimal moves how far? 1 spot to the right, and we get 2 point. Now remember, to the right of this 2 is just a bunch of 2's. Like it's an infinite number of 2's to the right of that. So we got 2 there, but don't forget the repeating sign. There we go. Now what do we do? Campbell, what do you think?
You subtract.
We subtract. So Campbell, what is 10n minus n? 9n.
Equals 2.
Yeah, the 0.2 repeating minus the 0.2 repeating is gone, right? It becomes 0. And then 2 minus 0 is just 2. Now, Benjamin, what do we have to do to solve for n here?
We have to divide.
Yep, we're going to divide by 9 on both sides. And we get 2/9. So n is equal to 2/9. Remember earlier I said we're just going to have that 7 hold its place as part of a mixed number? Well, 0.2 repeating is 2/9. So this is 7 and 2/9. Why is it what?
Why is it 2/9?
Okay. Number 4 on the day. Now that you've kind of figured out that we always have a denominator of 9, let me change it up so that we don't always have a denominator of 9. 3.36, where the 3 and the 6 repeat. Now, first off, think about what this number is going to be. This is 3.36. What comes after 3.6? 3.6. What comes after that? 3.6. This is 3.36, 3.6, 3.6, 3.6 forever. Okay? Now think back to the last problem. We said we got a number to the left of our decimal. It was a 7. And so we just took this 7 and we kind of stuck it out here as part of a mixed number to kind of hold that ones place, the whole number portion. And so we'll do the same thing with the 3. We're going to take this 3 that's to the left of the decimal. We're just going to hold its place here. And then what do you think n is going to be on this one? No. What?
0.36.
That's right, 0.36 repeating. So we have to figure out what is 0.36 repeating as a fraction. Think back on the previous problem. We said we have one digit repeating, so we multiply by 10, so we slide that decimal one spot to the right. What do you think we have to multiply by here? Bella?
100.
We have to multiply by 100. We have two digits repeating, therefore that decimal needs to slide two spots to the right. So when we do that, take a moment, see if you can figure out what 0.36 is, sorry, 0.36 repeating is when you multiply by 100. Lucy, what do you think?
36.
36 point, and then what's to the right of that decimal?
36.
36 repeating, right? Because remember, this is 0.3636363636. So when you slide that decimal two spots to the right, you've got 36 repeating forever still going on, okay? And then what do? We subtract, okay? Kyle, what's 100n minus n? 99n equals. All right, now, we always want these repeating portions to cancel out. 0.36 repeating minus 0.36 repeating, do they cancel out? They do. That becomes 0. What's 36 minus 0, y'all? 36. Okay. So, Olivia, how do I solve for n now? Divide by what? By 99, right? 99 and n, they're being multiplied, so we divide by 99 on both sides. So n is equal to 36 over 99. Are we done?
No.
Why not? We can simplify that. So everybody take a moment and simplify that fraction on your own. I'm going to pause the video, so if you're at home, pause the video too. So what can we divide by? 3, right? Matthew, what's 36 divided by 3? 12. And how about 99 divided by 3? 33. Can we divide by anything else? 3 again. What's 12 divided by 3? 4. What about 33 divided by 3? 11. So n is equal to 4 11ths. 36 99ths is the same thing as 12 33rds, which is the same thing as 4 11ths. Questions on that? So we slide back over here, and we say this is 3 and 4 11ths. 3 and 4 11ths is our answer there. Remember, whatever's to the left of the decimal, just write it down. It's going to be part of a mixed number, and then work on what is to the right of the decimal next. Questions on that? Okay. All right, so we got a tough one. This is the toughest one we're going to see all day here. Actually, I'm going to have you do one on your own before we get to the tough one. So try this one on your own, see if you have figured out what to do. And I'm going to be working behind you, and I'll have the answer up on the board shortly. So there you go. Convert 2.21 repeating to a, in this case, it's going to be a mixed number. Pause the video now if you're at home. Let's take a look here. 2.21 repeating. We're going to take this 2 to the left of the decimal, just kind of set it to the side. That's going to be part of our mixed number. Everything to the right of the decimal, but we're going to call that n. n is equal to 0.21 repeating. We have 2 digits repeating, so we have to multiply n by 100. This will move our decimal 2 spots to the right, and when we do, 21.21 repeating. We then subtract. Okay? 100n minus n gives us 99n. That's equal to this 0.21 repeating minus 0.21 repeating. That becomes 0. Okay? And we're left with 21 minus 0, which is 21. We now need to divide both sides by 99. So 99n. We divide by 99 to isolate the n. 21 divided by 99. So n is equal to 21 99ths. But we can divide both of these by 3. Make sure you simplify. We divide by 3 and we get 7 We divide by 3 and we get 33. So 7/33. 7/33. So 2 and 7/33. Any questions on that? Who got that right? Ooh, hot dog. Way to go, y'all. Proud of you. Okay, now let's work the next one together. It is quite challenging, so we'll do it together. Number 6 here. 0.35 repeating. Please notice where the repeating symbol is. Okay. What is the repeating symbol over? Just the 5. Okay, so here's how we do this. What do you think n is going to equal? Everything to the right. The only time we take a number out and plug it to the side is like right here when it's a number to the left of the decimal. Like we said, all right, 2's to the left of the decimal. So let's kind of write down this 2. It's going to be the part of our mixed number. But everything to the right of the decimal, we're going to say that's n. So 0.35 repeating, that is what n is going to be. What is the question we ask ourselves here? How many of the digits repeat? And so how many of the digits repeat here? Just one, just the 5. So this, if you were to write this out, it would be 0.355555555, right? So only the 5 is repeating. Are we good on that idea? Okay, so what do we have to multiply by? 10. We multiply by 10 because when we have one digit that repeats, we want to move this decimal one spot to the right. So when we do that, what's in our ones place now? Bennett, what do you think? The decimal goes one spot to the right.
5.
The 3 is in the ones place. Any questions on that? Now, if we move the decimal to the right, what's in the tens place now? 5. Now, before you write 5 repeating, that is correct. That is correct that there's 5 repeating, but we always want our repeating portions to line up. Do you see where the repeating digit is? It's in the what place? Hundredths place. So, as we slide that decimal to the right, there is a 5 in the tens place, and there is a 5 in the hundredths place, and it goes on forever. So you always want the repeating portions to line up. We good on that idea?
Would it be wrong if you underline or if you put the line over both 5s?
It would not be wrong. That'd be okay. And it wouldn't be wrong if you put it over just this 5. Like if you did this, you're not wrong, but it makes the next step more difficult than it needs to be. Just know the repeating portions always need to line up perfectly to make your life easier. Now what do? Subtract. What's 10n minus n? 9n. Okay. So here's why these repeating portions need to line up, because the repeating 5s, they become 0. What's 5 minus 3 here? 5 minus 3 is 2. What about 3 minus 0? 3. Okay. Now what do we do to solve for n? Divide by 9. So we divide by 9 on both sides. And so we end up with n is equal to 3.2 over 9. Now that doesn't look very pretty, does it? We have a decimal in our fraction, and we don't want that. So what can we do to 3.2 over 9 to change this so that we do not have a decimal in that fraction? Jack? Yes, so we're going to multiply by 10 over 10.
Why is it 2?
Why is it 3.2? Okay, why is it 3.2? Well, these repeating 5s here in the hundredths place and forever, like from the hundredths place on to the right, that's going to become 0, right? Because 5 minus 5 is 0, 5 minus 5 is 0, 5 minus, so those are going to become 0. They cancel out. In the tenths place, we have a 5 and a 3. So 5 minus 3 is 2. Bring down the decimal. 3 minus 0 is 3. And we divide by 9. So that's how we got here. Jack is correct. We are going to multiply by 10 over 10. And when we do that, we get what? 32 over 90. So now we have nothing but integers in our fraction. But can we simplify this fraction? We can. So take a moment and simplify that fraction, everybody. (16 over 45). We good on that? We in agreement? Okay. So this is equal to 16/45. Pretty crazy, huh? All right, now I'm going to give you a couple problems to do on your own. There's a shortcut for the first couple. Feel free to take the shortcut on the first couple if you know it. So we'll call this the practice section. Okay. Number 1 in the practice section is going to be 0.2 repeating. Number 2 in the practice section is going to be 0.6 repeating. Number 3 in the practice section is going to be 0.25 repeating, where the 2 and the 5 are repeating. And then number 0.2 repeating. And then number 4 is going to be 2.36 repeating, where the 3 and the 6 repeat. So try those 4 problems out. All right. Quick. First one, you should have had 2/9. Second one is 6/9, which simplifies to 2/3. Anybody get to the third one? I can give you the answer if you did. Okay, the third one is 25/99. So I'm going to send you homework in OneNote. Check it out. It'll be posted to Google Classroom as well. Thank you very much. Have a great day.